So now we're looking at a different rule of exponents, and it's called the quotient rule. So the first thing I'm asking is, what does it mean for a quotient? And that is just an answer to a division problem. And so our goal is to get comfortable with exponents so that we can start using them and applying them and have a better understanding of what they mean. So these first few days, we're really just kind of looking at how do we deal with exponents, and then we will work on how do we apply these, or what does it even matter, or how does this work. So the first thing, we're still going to start out the same way. We are going to write this into expanded form. And once it's in expanded form, we're going to go ahead and we're going to simplify. And to simplify, what we end up doing is if we have something in both the numerator and the denominator, we can cancel it out. And the reason why is because if I'm going to write this off to the side, x divided by x is equal to 1. Just like 5 divided by 5. If I divide something by itself, it's equal to 1. So if I can cross out all the things that equal 1, I can see what's left. And then with my numbers, I'm going to just see what goes into both of those. So what goes into both 4 and 2. And 2 goes into both of those, leaving me a 2 up on the top and just a 1 down on the bottom. So I'm kind of seeing, again, what's left. On the top, I'm left with 2x squared. And on the bottom, a 1. And I can simplify that to 2x squared. So I'm dividing exponents by seeing what I can cancel. I don't want it, when I'm done and simplified, I should not have both exponents in the numerator and the denominator. Because if I do, that means I could have canceled more. So I have one here where I have a whole bunch of 6s, and I can look to see what gets canceled out. These are just canceled in the middle, only because it's just easier. Instead of trying to draw a line between those, it's just neater to keep them here. So again, we're going to do the same thing. 100 to the third means I write out 100 3 times. I have to put multiplication between those numbers, or else it looks like I'm making this huge number, 100 squared. And then again, I'm going to cancel these two out because 100 divided by 100 is 1. 100 divided by 100 is 1. This is all that's left. So my answer is going to be 100 to the first power. T to the 15th. That's a lot of 15s. But we can write them out. 1, 2, 3, 4, 5. I'm going to put that in parentheses just to make it easier to count. 1, 2, 3, 4, 5. And I put a weird tail on my T's only because I want to make sure it doesn't look like a plus sign. So now I have 15 T's. You didn't need the parentheses. I just knew if I grouped them in groups of 5, it's easier to count. With 11, I'm going to do the same thing. And then what I can do is I can cancel them. Well, now I know that this whole group can cancel with this whole group because they're groups of 5. Groups of 5. Those two will cancel, and I'm left with t to the power of 4. So really what I'm doing is I'm taking however many I have, and I'm able to subtract them. So if you notice this t to the 4th, if I look at just these exponents here, 15 and 11, 15 minus 11 is going to give me 4. Because as I cancel them out, I'm technically kind of like subtracting them out. Just remember, whenever we have numbers in the front, though, we are not just subtracting those because we are truly dividing all of our problems. So on these, we can look at what that answer should be in the end by doing the subtraction. This is our proof. This is the way that we tell somebody that I know that this is x to the third, because when I write them out and I can cancel, I have 3 x's left, which means it's x to the third, because I'm multiplying x times x times x. If I have 2 variables, I just, again, just like when we were doing the problems yesterday, I write them all out, keeping track of what's the base and what the exponent is, canceling x's with x's, y's with y's, and I look to see what's left. And what's left is 1x and 2y, so xy squared. When I have coefficients, what I'm going to do with those coefficients again is just work on dividing. So I might, and I do them at different times. On this particular one, I'm going to go ahead and take care of my coefficients first, because I want you to really focus on that. It's almost like I'm looking at just this. Negative 36, the first thing I'm going to do is see if 6 goes into 30, and it does. So this would cancel, and it leaves me with a negative 5 over 1. So I know my coefficients are just a negative 5. And then I have 3 x's and 6 y's. Just going to move that just a little bit closer. On the bottom, we already took care of the numbers. That's where we got the -5. So I'm still left with an xy. X's can only cancel with x's. Y's can only cancel with y's. So I'm left with -5 x squared y to the 5th. And if I looked at those exponents, 3 minus 1 on the x's would have left me with an x squared. 6 minus 1 would have left me with y to the 5th. So we should be able to figure out that answer, and then we're just proving it. So pause, try the next one, see if you get it, and then go ahead back and check. So when I'm looking at this one, I have a negative divided by a negative, which means that my answer is going to be positive. I'm just going to switch that. 4 does go into 20, and it leaves me with a 5. So I'm going to cancel those. So I have a 5, I have a z, I have 5 x's. Oops, that should have been an x. 4, 5, and then I have 6 y's. 1, 2, 3, 4, 5, 6. We're just going to write them out and see if I can move this any closer. A little bit. Divided by just an x. So my x is going to cancel with one of my x's. I have 5. X to the 4th. I'm just putting them in alphabetical. If you put the z first, not a big deal. Y to the 6th, z. Being able to manipulate those numbers. Our last one here, we have a 10 and a 30. So I know that 10 goes into 30 3 times, so I'm going to keep it there. It's like a third. It's in the denominator. A is written out 4 times, and a B. 3 is in the denominator. 2 A's, 5 B's. Again, I cancel. A's cancel with A's. Looks like I left one there. B's cancel with B's. So in this case, I'm left with an A squared in the numerator, and in the denominator, I have 3 and 4B. So 3B to the 4th. It's okay if whatever I have the most of. So if I look at my B's, I can tell there's more B's in the denominator. So that tells me I should have more B's in there at the end. So we're just really kind of trying to train our brains to be able to write things out and to be able to simplify them. And then hopefully it will help us to remember what it means to be an exponent and how we multiply those out. Our numbers, we're dealing with our numbers the same way we have for years, with how we're simplifying them. And our exponents, it looks a little different with what we're doing with those, but really what we're doing is canceling out where they repeat. So solving that quotient rule, the first thing I like to do is simplify coefficients. And I just look at it as a fraction and reduce that fraction. So I'm going to put that in parentheses to reduce fraction. It's dividing and fractions are exactly the same thing. The second thing we do is we write it in expanded form. So expand. And then we simplify, if we cross out variables if they're in both the numerator and the denominator. And the last thing is to simplify what's left. If we have a bigger number in the denominator, it's just like this last problem up here. And when we have that bigger number in the denominator, it just means that's where the variable is going to end up. So when we're looking at this question, what happens if the bigger exponent is in the denominator? That is where the variable will be after simplifying. And the coefficients, you just simplify. Think reducing fractions.